Have you ever wondered how the human brain, a 3-pound organ, holds a lifetime of memories? It's quite a marvel, isn't it? This intricate network of neurons, synapses, and chemicals that we call our brain is capable of storing an astounding amount of information. Memory, the keeper of our past, is a complex and crucial aspect of who we are. So buckle up as we delve into the fascinating world of memory and how our brains make it all possible. Imagine your brain as a supercomputer with billions of neurons working together to create your memories. Isn't that amazing? Let's delve into the science behind memory. Our memories are formed, stored, and retrieved thanks to a complex network of neurons or nerve cells in our brains. Each neuron connects with others through tiny junctions called synapses. When we learn something new or have a new experience, our neurons send signals to each other across these synapses, creating a unique pattern. This pattern of neural activity is what we call a memory. The process doesn't end here. The signals that neurons send to each other are carried by chemicals called neurotransmitters. These neurotransmitters help strengthen the connections between neurons, solidifying the memory. Now, let's talk about the types of memory. First, we have short-term memory. This is like your brain's notepad, holding onto new information for about 20 to 30 seconds. Think of it as the information you keep in mind while dialing a phone number you just looked up. Next up is long-term memory, which is more like your brain's filing cabinet. It's where you store information for longer periods, from minutes to a lifetime. Your first day at school, the name of your childhood pet, these are all stored in your long-term memory. Lastly, we have sensory memory. This is the briefest type of memory, and it's tied to your senses. It allows you to retain impressions of sensory information after the original source has vanished, like the lingering smell of freshly baked cookies or the fleeting image of a bird flying by. Each of these types of memory has a distinct role in how we perceive, understand, and interact with the world around us. They're all part of the intricate dance of neural activity that helps us remember. These complex processes happening in our brains allow us to remember everything from our first birthday to the taste of our favorite food. A memory's journey is a fascinating one. From the moment of perception, it goes through a series of stages before it becomes part of our long-term memory. The first stage in this journey is encoding. This is where our brain takes in information from our senses and converts it into a form that our memory system can use. It's like a translator, turning the sights, sounds, smells, tastes, and feelings of an experience into a language the brain understands. Next up is storage. Think of this as the brain's filing system. Once the information has been encoded, it needs a place to be kept. Short-term memories are stored in an area of the brain called the prefrontal lobes, while long-term memories move deeper into the brain to the hippocampus, where they are organized and categorized for easy access later on. The final stage of this journey is retrieval. This is when we recall the information stored in our memory. It's a bit like finding a book in a library. The brain, acting as a skilled librarian, sifts through the shelves of stored memories, locates the one we need, and brings it to the forefront of our consciousness. Each stage of this journey, from encoding to storage to retrieval, plays a crucial role in our ability to remember. Without any one of these stages, our experiences would remain fleeting, unable to be relived or learned from. This journey, from a fleeting moment to a lasting memory, is an incredible feat of the human brain. While our memory is a powerful tool, it is not infallible. As remarkable as our ability to remember is, it comes with its own set of limitations. For one, our memories are not always accurate. Often they are susceptible to distortion and can be influenced by a variety of factors. This is known as memory distortion and can lead us to remember events differently than how they actually occurred. Memory loss is another limitation. As we age, our neurons gradually lose their connections, leading to memory loss. This can be due to normal aging or more severe conditions like Alzheimer's disease. However, there's a silver lining. Enter the concept of neuroplasticity, the brain's potential to reorganize and create new neural pathways. This capacity of our brain allows for improvements in memory function and offers hope for those facing memory-related challenges. Understanding how memory works can not only help us appreciate this intricate system, but can also guide us towards ways to enhance our memory capabilities.